I'm going to get started. Can everybody hear me? Is the mic working? Cool. So I'm going to talk about Empower Engine and how we use caching to allow us to create tons of maps and auto-update the data on some of them. So first of all, I'm going to talk about who Empower Engine is, what we are, what we do, what the system is. Show you how we make tons of maps and tons of map tiles. Then I'm going to talk about how we cache the data for each map, and then I'm going to talk about how we use caching for the data that we update daily, and then I'm going to talk about some Postgres and PostGIS tips and tricks that I'm using to speed the system up as well. So Empower Engine is a two-person company. We do map-based data visualization for Democratic campaigns. I've been a software engineer for over 15 years, and I got involved in Democratic politics on the Dean campaign and then Kerry Edwards, and I've been working in Democratic campaign tech for a long time. My business partner, Noah, got started in politics doing field work for Obama and made individual maps as one-offs using more desktop tools and such for campaigns, and then and he does more of the UI stuff, and I do the back-end engineering. So the thing to know about campaigns is that they organize geographically, so maps are very important, though they're not used the way they should be, which is why we've built the system. Organizers on campaigns are each in charge of their own turf, their own geographic area, so they want to know and understand data about that area, and they don't care as much about the rest of the world. So the local variation matters. So this is the set of doors that the campaign wants to knock, but this is the set of doors for one organizer on the right who's in charge of this area in the suburbs of Seattle, where a dense precinct, as you can see, the red precincts have between 500 and 1,100 people per square mile. And this organizer, who's in charge of this area in Southwest Washington, which is more actually the suburbs of Portland, Oregon, a dense precinct there is 1 to 200 people. So you really want to know about the local variation when you're working in an area. And the best way, the clearest way actually to see how much local variation matters and why you want to scale your data is looking at election results. So in 2012, My Right to Marry was on the ballot in 4 different states. I'm proud to say we won all 4, first time that's happened. And in Washington State, where I live, we won by 7 points, the biggest margin. And so if you look at the results statewide and you zoom to Seattle, Seattle is just solid dark blue. Everyone believes in marriage equality in Seattle. It's part of why I like living there. But if you're doing work in Seattle, that doesn't tell you a hell of a lot. What you want to see is where we won by 5% versus 15% versus 50%. And so if you make a map just of the Seattle election results and scale it to Seattle rather than making a statewide map and zooming into Seattle, you can see that local variation. So that's what our system was designed to do. And technically, what this means is that we have to make maps at any scope on the fly of any data layer that's in our system and at any granularity. So it might be precincts, it might be census blocks, it might be hexagons, and we have to do all of this in the web request response cycle. So that's the challenge, that's the technical challenge I was facing. So to give you just a quick demo of the system, when you log in, the typical organizer sees a whole bunch of maps at the district at which they're working. Usually these are 4 columns, but it's scaling it more as if it was a mobile for some reason. So you might zoom in. If you're learning about your district, you may want to look at the median age of people in your district. You may want to look at the racial makeup of your district, and you can see that there are a lot of Asians in this district and some Latinos, but hardly any African Americans. And you can also, though, change things about a map and make a new map on the fly. Oh, and of course, we're also using UTF-grid, so you can mouse over and see the actual data. But so this is a map of, it's called universe density, or I think it might be penetration, whatever, in the 45th legislative district. And I can change it from being a map that's done precinct by precinct to being a map showing the data at the hexagon level. And that inherently shows density. And so you may want to look at that. You can also switch the data layer that we're showing. You can switch it from being a map of the 45th to being a map of the 44th, or of any city or town. This is data from a specific campaign that lets us demo with their data. So I have to pick places where I know I have data to show. So that's a quick demo of the system. And I'm going to get back into the technical stuff now. So our stack, we are using Postgres and PostGIS as our database, of course. We are generating and serving our tiles using Tilestache, or really a wrapper I made around it. And we are using the Mapnik library to generate our tiles. And we're not using vector tiles currently. It's image tiles and UTF grid tiles. And then we cache our tiles on S3. The system that I logged into to show you all those maps is a Django application, which is Python. Of course, we're using the Leaflet library for showing the maps, and Celery we use for queuing processes. So I shouldn't need to tell anybody in this audience that we use maps, because they empower and tell a story where spreadsheets don't, and they empower and motivate the organizers, the volunteers, even the candidates themselves love to see that the work they've done so far on the campaign, knocking on doors and such, has been adding up, because it just feels like an endless process when you're knocking on all the doors in a state legislative district, say. But the organizers, our users who are making maps and looking at maps, don't need to know what a shapefile is, and they shouldn't need to. We take care of all of that behind the scenes. So this is a quote from one of our users, one of the organizers. She basically said she loved the system because she could show a map of where the doors were that she wanted people to knock on, and instantly they were willing to drive 20 minutes across town because there were a lot of doors to hit over there, and where they'd want to go, which is right by the office where they were getting their lists, we've already knocked all those doors. There aren't that many people to talk to right there, so they're happy to drive across town once they see it. So generally what Empower Engine does is it makes it very easy to create and edit choropleth maps. And generally any user can make maps, or most of our users can make maps, but the campaign manager generally makes a set of, quote, distribution maps that they think are important, and then they distribute those to all of their organizers, and the organizers get copies of those maps, but rescaled just to where they're working. It rescales and reclassifies the data for each person where they're working, and that's the key thing. And some of the data layers that we're showing on maps are static data, like census data, to help you get to know your district and understand it. But the ones that keep people coming back and logging back in every single day are the ones that change every day. Where are the doors that we've knocked in the last week? What is the density of the people I want to talk to today? Where is that densest? And that will change every day, because if you talk to somebody yesterday, they're not on your list of people to talk to today. Where people voted so far once voting has begun. So now I'm going to get into how we serve so many maps and so many tiles, which I said was basically Tilestache and Mapnik. But the problem with Tilestache is that by default, you set it up the way it comes, you have a configuration file that specifies every map that you're going to have. Well, we can't do that because we're changing maps all the time and making new maps all the time. And it does, out of the box, that you can pre-generate your tiles, or you can generate them on demand writing a custom provider. There are hooks for that. And it has a lot of great hooks for caching tiles, including on Amazon's S3, and that's what we use. And this is both image tiles and UTF grids. But we can't use it, the S3 cache or the custom provider, the way it is out of the box, because we have dynamic sets of maps. So I've written a custom wrapper around Tilestache that lets you specify any set of parameter names, and then it passes those to your custom providers and to the caching classes. And so what I use is map ID and version. And so the map ID will tell the custom provider that uses MapNIC to make the tiles what data layers are on the map, what colors it's using, how it's binning, where to find the data, so on and so forth. And then the cache inserts the map ID and the version into the S3 path. So anytime you make any change to a map, like you change whether it's precincts or hexagons, it just ups the version and invalidates the tiles. So here are two tiles of the same area, same map, but a different version. And this is just the path onto S3 for these two tiles. So now I'm going to get into caching for individual maps. So first of all, why do we cache stuff? Well, my system didn't even work everything timed out before I was caching, but space is cheap and geometric queries are slow, very, very slow. Index lookups are definitely fast in the database, but if you can just query against a small table rather than having to do any joins and where clauses, you're going to be even faster. And I'm making tiles on the fly and generating new maps within the web request response cycle. And I'm also updating data every day and I want to do that as quickly as possible. That process can't take hours and hours and hours. So just to give you a scale of what I'm working on, I have about 6 million Washington state districts, and that's just one state. That's the state where we did most of the work in 2014, but we are getting into many more states now. And we have about 27 million attribute values. So this might be the number of votes for marriage equality in an individual precinct, or the number of doors attempted yesterday in a specific hexagon or a specific precinct, or the number of doors attempted last week in that specific hexagon, specific precinct, so on and so forth. So nice thing about cache tables is you can always recreate them. You don't have to worry about the data in them. So XKCD has a good one on that. So to make tiles efficiently in MapNIC, I don't want MapNIC to be doing any joins or anything because it is doing geospatial queries to generate each tile. And my district shapes table, which has all the shapes, is huge. It's 6 million rows just for Washington state. And the same thing with the values table. So I don't want MapNIC looking at those tables. The smaller the tables it's looking at, the better it'll perform. So what I've done is I've made a cache table per map with all of the data values and shapes just for that map. And so here's a sample map cache table definition. It has the district ID, it has the values for every attribute, and that might be the number of votes for marriage, or it might be the number of African Americans in the district, or it could be anything. But so we have the attribute values, we have the geometry for that district, the name of the district, the square mileage of the district, so on and so forth. Now these cache tables definitely speed up tile generation. but they also have to be created efficiently in the first place. And so I don't want to do any geometric queries to determine what data will be on a map. So what I've done is I've pre-calculated everything. I can't pre-generate all the tiles because that's impossible, but I pre-calculate all of the possible granularities and all of the possible boundary scopes. So the set of medium hexagons in Puyallup, I've got that. The set of medium hexagons in any congressional district, I've got that. The set of 2012 precincts in any town or congressional district or state house district or what city, I've got that. And so when I'm pulling any data layer in any scope, any granularity to make my map cache table, I'm joining on indexed IDs, integer indexed IDs. Yes, this takes a lot of time to pre-compute, and I've done some work to optimize that. I'd like to do more, but it's a one-time cost. And I just can tell a state that if I'm bringing up Colorado as I'm actually doing this week, it'll take me a week to get your state up and running. It's only about an hour or two of my time because I'm just kicking off scripts, but some of those scripts take a long time to run. Now I'm going to talk about the data that we update every single day and how we do that. So I'm working in the campaign space, so it's universe density. A universe is the people the campaign wants to contact. It's universe penetration, so what percentage of the people that we want to contact in this period of the campaign have we contacted so far? Of the people that we know are going to vote for us, how many of them have voted so far? All of the doors or all of the doors we've knocked on, all the calls we've made in the last day, in the last week, since the primary, so on and so forth. But yes, I'm talking about campaign data for my application, but if you had any big data set that was geocoded, you'd have the same problem. So if you were making maps of tweet density, it would be the same thing. So every day I pull down data from the DNC's data warehouse, which obviously isn't a public site, but I can access it. If a campaign says I have access to it, the DNC will give me their data. And the thing that's useful to know is that a voter is going to be likely in different data sets that come from the campaign. The same voter is likely to be in multiple of them. And the same voter might even be in targets for different campaigns. So I aggregate, I pull down all my data per voter ID, and then I pull down the voters with their geocodes. And then I can aggregate, and then I can do stuff by voter. So I aggregate all my points to polygons because I don't want to, because I have the overplotting problem otherwise. Because I'm pulling down data about 4 million voters just in Washington State in the GOTV is Get Out the Vote, the final 3 weeks of the campaign. I'm talking about 700,000 contacts and attempts. So in any given area where I'm working, there are zillions of points, so you aggregate everything. And what I do is I make a lookup every day of the people I'm aggregating data about to each district that they're in. So to each hexagon that they're in, to the current precinct that they're in, census blocks potentially, so on and so forth. But I make these cache tables every day because they do change a bit. And then I aggregate all of my per voter data by just joining to this table, grouping on district ID. That's what databases are great at and are optimized for. So as I said, these person district mappings change every day, but not by very much. So in my example, Jennifer and Amanda move in together, and at this geocode, it's in this specific medium hexagon with some district ID. It's in this specific precinct with this district ID. And if Jennifer moved in with Amanda, we may already know the district, but they may have rented a house that belonged to a non-citizen, or frankly a Republican, and we may have to geocode the district. But hopefully they don't move again, they don't break up, and they're unlikely to move again before the end of the campaign cycle. So a lot of people actually share geocodes. It's couples, but it's also families and whole apartment buildings sometimes. So I have a lookup table of person ID, lat long, district group ID, which would be hexagon or medium hexagon or current precinct or whatnot, to the district. And so I can answer the question, what large hexagon is Jennifer in, given that she lives at this geocode? And if I don't have an answer to that already in my lookup table, I can check if I already know what large hexagon is this geocode in, and without having to pre-compute it geometrically. When I do district new geocodes, because there are always going to be some, I pull a distinct list of geocodes to district, and in practice that speeds things up by 2 to 3 for me. And I also have my ginormous district shapes table, but I also have a cache table for every district group that I'm that's a granularity, so that I can, if I'm looking at what medium hexagon these geocodes that I'm districting are in, I just look at the shapes for the medium hexagons, and I should say the Washington State medium hexagons, because the Colorado medium hexagons are a different district group. I do everything state by state. And then, of course, once I've done this, I add it to my lookup table, because chances are we're going to be making maps about Jennifer and Amanda tomorrow. So once I have my lookups, I can make my daily person to district lookups, and then I can update all my data sets, grouping on district ID, and I also pre-compute and store for all of my districts the square mileage, so that I can compute people per square mile just as easily as number of people, because sometimes you want to look at one, sometimes the other, and often you want to, when you mouse over, will usually show both. So updating my maps are very easy. I store on every map when it was last viewed, and I store on all of my data sets when I last updated the data. And so if the data is newer, it's just like when I've edited a map, I recreate the cache table, I recompute the bins, I increment the version, and going back to what I was talking about in the beginning, that invalidates the tile cache on S3, and all of the tiles get made anew. So just as a reminder, the problem I was looking at was making maps of any scope in any data, showing any data layer at any granularity in the web request response cycle. So here are two maps. One is of Puyallup, one is of the 45th Legislative District in Washington State. One is showing the people contacted at the door. One is showing the percentage of targets, or I think percentage of all people who have voted early. And this, one of them is a hexagon map, and one of them is a precinct map. So now I'm going to get into just some Postgres and PostGIS tips and tricks. Postgres, whenever you define a table, you say that this is an integer column, and this is a varchar column, and so on, a varchar 12 column, and so on and so forth. And that's because Postgres is trying to store all of the data for a row adjacent, and it knows how much space is needed for an integer or a character, but it doesn't know how big a geometry is. It could be arbitrary. So geometry columns hold pointers to shapes, and those are stored somewhere else. And so that slows down usage of that districts table often. So what I've done is I've separated my districts table from my district shapes table. And they're one-to-one with a shared ID. But if I don't need the shapes, I don't have to access that table. And indexes are great when you're for speeding up joins and such, but not all indexes are created equal. Integers are the fastest thing you can do. Floats are a close second, but they are second. And geometric indexes are not nearly as good. And so when I'm checking if I know the district for Amanda at this geocode, I'm going to use the voter ID first rather than just looking up the geocode. And when I do look up the geocode, I store it as 2 floats, as a lat long, so that we can use the native Postgres float indexing. I also, you saw me in the beginning switch a map from being of the one district to being a different district, and I have multiple places where where we have an autocomplete for selecting the boundary scope of a map, and that page started to crawl and time out when I loaded more precincts, or I think when I started using hexagons. And I realized the problem was it was searching my table, doing a text search of my table of millions and millions of districts. Well, we're not actually going to be making maps of hexagon 1, 2, 3. We're going to be making maps of congressional districts and counties and cities, and just showing the data by hexagon. So I have millions of districts that are only ever used for granularities, and only thousands of districts that you're ever going to be selecting in this way. So in Washington State, 6 million granularities, 768 potential boundary scopes. So that's where materialized views are great. I have a materialized view for all the districts that can be boundary scopes, and anytime I load new districts, I just can refresh the view. So far, I haven't needed a text index on the view, but once I get into, once I'm working nationwide or internationally, it would be very easy to add a text index on the view. So, because it's a materialized view. So, and now I'm going to open it up to questions. And I guess I talked fast because I timed it as longer than I took. So, yes?
For the hexagons that you're creating at different sizes, is that data aggregated or interpolated from the others? And that pose any challenges?
What do you mean? So when all of the data that I show at the hexagon level is data about individual voters, so I just can count the number of voters in a hexagon. I'm not trying to figure out, I'm not going to try and translate election results, which are only available at the precinct level, into hexagons. So I'm just counting the number of people with this characteristic, or the percentage of people with this characteristic in each size hexagon. So. Yeah. Yep. Yeah.
I missed the very beginning. What do you use the Leaflet for? It seems like you're putting everything in tiles.
I'm using Leaflet to serve the tiles. So this is one of my maps.
Are you overlaying?
Yeah, I'm overlaying image tiles. I'm generating the tiles using Tilestache, both image tiles and UTF grid tiles. And then I'm overlaying them on tiles. So, yeah.
I'm just curious, so if you had to write a wrapper around Tilestache to do this parameterization of the layers, why didn't you use a different cache that supports that automatically, like GeoWin cache?
I don't really know about what is Geo Web Cache?
It's another tile caching server. Similar to Tilestache.
But well, Tilestache, I'm also making the maps. I'm also making the tiles dynamically on the fly, and I don't. So does that have a?
Yeah, it talks to a WMS on the back end, or I guess maybe Magnet does whatever.
I need to generate the Tilestache serves tiles, but it also lets you write custom providers for making the tiles using MapNet. So I'm not.
Would have been about the same amount of work either way.
So I'm not using, because Tilestache, you can also like produce all your tiles in TileMill, but we can't produce all of our tiles in TileMill because we're making maps on the fly all the time. So we're using a custom provider and rendering them on the fly. So that's why I'm using Tilestache, was it was built for that, or kind of. So, sure, you.
Do you start a new Tilestache process every time?
No, that's the key thing that that was what I did with my wrapper of Tilestache, is that it I've written a wrapper for Tilestache that lets me specify parameters that get passed to my custom provider and to the cache. And so this is the cache that path, the S3 path, has the map ID and the version, because I have said map ID and version are the parameters I'm using. But it's general that you can just say, I want to use parameters foo, bar, and baz, and then it'll pass foo, bar, and baz to your custom provider and to your caching classes.
Okay, and then the provider pulls it out of the database?
Exactly. So, back.
So do you have Leaflet pointed directly at S3?
No, Leaflet goes to Tilestache, and Tilestache says, is this in my cache? If so, return it. If not, generate it. That's built into Tilestache, or generate it and then put it on S3. And so what I did was I said, do that, but also include these additional parameters of map ID and version when you are creating the.
The reason I ask is because you can actually point it directly at S3 and have S3 do the redirect to Tilestache if you want. You could actually flip it.
Huh? Would that be fast? I wonder if that might be faster.
It could be faster if the data is there, right? If you have a lot of data created, then all the subsequent requests will be much faster.
Yeah, I think that most of the time, or quite often, the data, because most of the data that we're looking at, you look at every morning afresh. I think S3 is nice because it definitely speeds things up, but when it's already there, but so much of the time we are actually generating tiles, probably 50%, you're looking at a map. I mean, sometimes you'll have two organizers in the same turf, so one of them may look at the map and then the other one will log on an hour later and look at the same map. So it'll speed it up for the second person, but yeah.
I think it would be a lot faster if we had a large number of people. Like these.
Yeah. In the middle and back.
When the map version increments, how do you clear the old tiles from the cache? Or is that something Tilestache does automatically?
When the version increments, the path is different, so it's not going to look at the old cache.
Right.
And so I can just leave them on S3. At some point, I was going to write this whole code to try and clear old caches on S3, and I was looked at it, and I was being charged about, at that point, $1 a month for all of the tiles on S3. It's probably now up at $5 or $10 a month, but it hasn't, unless it gets into the hundreds of dollars, I'll just let it be. And frankly, what I could do is probably just go into S3 and delete everything and then just start recaching, especially since it's between campaign cycles right now.
So approximately how many tiles per version are you caching?
It totally depends if somebody logs on and zooms in or not, and how often somebody changes this map. And if this is static data that a lot of people have access to, there are probably there could be hundreds and hundreds of tiles of this map. But if this is data that updates every day, you're probably not going to have lots of people zooming into different areas, so you're not going to have nearly as many. So it really varies. So.
What zoom level do you cache down to?
However far they will, they want to see, because we don't cache it, we don't create it until somebody's viewing it. So we don't pre-cache and pre-generate anything, any tiles, so we don't have to worry about zoom levels. And so often you will probably have people zoom in on a statewide map, zoom in very far in Seattle, but they're never going to bother zooming in very rural areas. You're probably going to, yeah, so it varies, but we don't have to worry about that. That's the nice thing about generating tiles on demand.
And then do the users, you get many complaints of people complaining between a cache, when they hit a cache versus an uncached layer? Like, what's the performance difference?
It's not that bad. So if I make a new map, so if I open this map, because it's already been cached, you can see it's pretty fast. But I just edited this map, but here we can edit it again, and so it'll have to generate all of the caches again. So if we switch the granularity, this is just the easiest way to edit a map. Switch it to precincts. Could switch it to big or small hexagons too. Our big hexagons are 1 square mile, medium are 0.1, smaller 0.01. So that's how long it took to generate a map. And if we zoom in, it's generating all the tiles on the fly there. So it's pretty fast, even when it's making them. And that's because I have the map cache table with just the data for this map. And the tables, when I recreate a table, the other map cache tables go away. I delete the table if it exists and recreate it. So, more questions? Yes.
Yeah, you mentioned that maybe we have created a gathering here using vector tiles, and just wondering if you have some tests and if you think it might change the workflow completely.
I can't hear what you said, sorry.
I'm just wondering if you decide to move to vector tiles, is that going to change your workflow easier or not so much?
I'm just starting to explore vector tiles with another mapping application that we're going to build for campaigns. So I don't know enough I don't think it would change it that much. I think I would still want my map cache tables when I'm generating the vector tiles. So it might be that I might be able to pre-cache different types of vector tiles with all of my geometries, that's probably what it would be, is I would cache all of my geometries and all of my scopes at those tiles without any data, and then I would probably layer on the data. So when I make this map, when I switch it back and forth between hexagons and precincts, only the first time that you make a hexagon map of the 44th would it have to generate those vector tiles. After that, it could reuse those, and it would just make additional vector tiles for the data set. And then you can just combine them. So that's possibly, and where it would go. So, other questions? Yeah.
Your PostGIS database, is it run on the Tilestache or Tilestache server, or is it running on RDS separately?
It's on RDS, and then our tile server isn't currently even on Amazon. It's on Linode, but we are thinking of moving it to Amazon specifically to have less latency between the two things. But we use Amazon RDS rather than running our own database server, just because of all of the nice point-in-time recovery and everything that Amazon manages for me. There are a few things that I wish, like extensions that I wish I could install that I can't because I'm using Amazon RDS, but before Amazon RDS supported Postgres 9.3, we were running our own and it was much more brittle, so it's a worthwhile trade-off.
So getting the tile server closer to PostGIS, is that your performance bottleneck? Is that between the RDS and your tile server? Is that a bottleneck?
Is that a bottleneck? I don't know. I think it's always a bottleneck. Communication with the database is always a bottleneck in any web application. So if I can bring it closer in, I think it would help because I would have them both running on the same Amazon cluster. Because with Amazon you can say like use the data center in Oregon or the data center in Virginia, and so I would have them both I would have them all in Oregon if I did that. So, more questions, comments? I think we're out of, go ahead, last question.
Could you put up the link to the list?
It is, if you just search for Julie Goldberg on GitHub, you'll find it. And I'm going to try and figure out how to put these put the slides up if they don't, but GitHub, Julie Goldberg, and I think it's the only thing I have there, so. I need to get more stuff on GitHub at some point. So, okay, thank you.